Hello, class. This is Dr. Nunez. Welcome to the Chapter 23 problem-solving session. So we're looking at evaluating variances from standard costs. Now, what I'm going to be doing in this problem-solving session in evaluating variances is using the basic approach to variance analysis that's introduced in the chapter and that I used in the lecture. So when we look at materials variances, we're going to take this approach. We're going to look at the direct materials price variance, the direct materials quantity variance, and when you put the two together, you've got a direct materials cost variance. And the variables that we're going to need. So let me make a note here for you to make it easier for you to follow along, because every one of these that we do, we're going to use the same abbreviations. So on the far left here, when we evaluate a direct materials price variance, we're looking at AQ times AP. What is AQ? AQ is the actual quantity. And the AQ times AP, what is the AP? That is the actual price. And in the middle here, we're looking at the AQ. Well, I just defined that. That's the actual quantity, but times the standard price. So the SP is the standard price. And then on the far right, it's the SQ times the SP. So the SQ is the standard quantity. So we have defined all of these abbreviations here, right? The AQ is the actual quantity. The AP is the actual price. Again, the AQ is the actual quantity. The SP is the standard price. The SQ is the standard quantity, and the SP is the standard price. So for all of the exercises where we are required to calculate the materials variances, we're going to be using those same abbreviations and this same model that you see here. So I suggest that you make a note of this model so that you can use it when you solve the homework problems, when you work on the application assignment, and when you work on the quiz, because it's the same basic model. So let's use this model for this first exercise, exercise BE, basic exercise 23-1. So let's make a note of what we're given here. We've got some information that we need to be able to evaluate. We are given information about the standard pounds that are needed per unit. I'm just going to highlight the givens, if you will. So a product that requires 3 pounds of this raw material per unit. That's what we're going to use to get the standard quantity. And the standard price, well, the price is $6 per pound. And they actually used 23,900 pounds in producing 8,000 units. And they purchased at $6.20 per pound. So if I could go back and kind of fill in some of this information, they used 23,900 pounds. So that actual quantity here, I think it's easier if I type. The actual quantity here is 23,900 pounds. So they actually used 23,900 pounds. And the actual price, well, the actual price that they paid is $6.20 a pound. So the actual price, I think I'll just put that here, is $6.20 per pound. And the standard price, well, the standard price that we're given is $6 per pound. $6 per pound. And the standard quantity, well, the standard quantity is going to be based on 3 pounds per unit. 3 pounds per unit. So what's happening here is 8,000 units were produced. 8,000 units produced. And each unit requires exactly 3.0 pounds of this raw material. So if they made 8,000 units and the standard is 3 pounds per unit, then they should have used 24,000. So if I could, that's 24,000 pounds, which we define as our standard quantity. So this standard quantity is, in essence, the standard quantity that's allowed for the actual output. So given that the output is 8,000 units, that's here, and each unit requires 3 standard pounds per unit, then the standard quantity for all the output is 24,000 pounds, 8,000 units times 3 pounds. So we have all of these variables identified. The actual quantity is 23,900 pounds. And the actual price is the $6.20. So the actual cost, if you will, 23,900 times the $6.20 is $148,180. That's the actual cost of those materials. Now, what should those materials have cost? So if we actually use 23,900 and the standard price for a pound is the $6, then what it should have cost is 143,400. So 23,900 times 6 is 143,400. And the way we get a price variance is by subtracting the 148, 180 minus the 143, 400. That gives us a direct materials price variance. And I'm gonna list that here. That direct materials price variance, actually, I think I'll just move this up a little bit. That direct materials price variance is $4,780. And for every variance, we need to be able to identify it as being favorable or unfavorable. Well, this is a positive number. Positive numbers are going to be unfavorable. And you can identify that as being unfavorable because of the price. The actual price of $6.20 is more than the standard price, right? The actual price of $6.20 is more than the standard price of $6. That's why that variance is unfavorable, right? It's unfavorable because they spent too much, right? The materials cost too much. The materials cost 20 cents more than they should have given the standard, hence an unfavorable direct materials price variance. Now, let's also calculate the direct materials quantity variance. And here we're going to need that standard quantity that we calculated initially. That's 24,000 pounds. And we want to multiply times that standard price. And the standard price is at $6 again. So the standard quantity at standard price is 144,000. And when we calculate our quantity variance, well, it's the 143,400 minus the 144. And we've got a negative number. We end up with a negative 600. Negative variances, and if I could go back and put in some brackets here, negative variances are favorable, right? A favorable impact on our profit. Why is it favorable? Well, because we use less, right? It's a quantity variance and we use less. So let me highlight that. We only use 23,900 pounds of the materials, but given the output, we should have used 24,000 pounds, hence a favorable variance. So the quantity variance is favorable because we use less. The price variance is unfavorable because it cost more. And when we put it all together, that's what we end up with and call a direct materials cost variance. So when we take the 148, 180 minus the 144, the two ends, the numbers on the two ends, right? This number, 148, 180 minus this number, 144, it gives us a direct materials cost variance, which is for 180. And what is it? It is unfavorable. Why? Well, because it's a positive number, right? Those positive numbers, because the actual cost more than the standard. That's why it's unfavorable. The actual number cost more than the standard cost, and hence a total direct materials cost variance of 4,180. And it is, in fact, the net of these two variances, right? If you take that 4780 minus the 600, you get 4180, an unfavorable direct materials cost variance. That's our basic model. Again, identify all the variables and then just plug them into the model, calculate the variances. Now, when we calculate our labor variances, the model kind of looks the same. The headings are a little bit different, but the model looks the same. So let's go back. Let's scroll down to the next one, which is the direct labor variances. So again, we're going to be provided with some basic information. Let me identify that up front. So we've got a product that requires 7.5 standard direct labor hours per unit. That's how we'll get the standard amount of direct labor that's needed. And the standard rate is $22.50. And they made 8,000 units, and they actually used 60,200 hours at a rate of $21.95. And we need to calculate those three variances. So again, I want to upfront identify the abbreviations that I'm using. So right here, I'm just going to type them in. So AH, what is AH? AH is the actual hours. And the AR, well, AR is the actual rate. And so AH is actual hours, AR is the actual rate. Again, AH is actual hours, SR, that's the standard rate. So the SR is the standard rate. And SH, well, SH, standard hours. And again, SR is the standard rate. Now let's plug in the givens, the numbers that were given. So what we know in this case is that we do have some actual hours. They actually worked 60,200 hours. So they actually worked 60,200 hours at a rate of $21.95. So they actually paid their people $21.95 an hour. And the standard rate, well, the standard rate is $22.50 per hour. So the standard rate of 22.50 per hour. Let me make sure I note that as being per hour. And then lastly, the standard hours. How are we going to get the standard hours? Well, so again, if we think back to the previous problem with the materials, the standard hours is going to be based on the amount of hours that they should work given the output. So in this case, they made 8,000 units. 8,000 units, and every unit requires 7.5 direct labor hours. So times 7.5 hours. That's what every unit should take. That's a total of 60,000 hours. So the standard hours are going to be 60,000 hours. Well, those are all the variables we need for this basic model. So the actual hours, 60,200 times the actual rate, 21.95, is going to give us the actual cost of that direct labor. And the actual cost of that direct labor is $1,321,390. That's what that labor actually cost them. It actually cost them 1,321,390. And if we take those actual hours, the 60,200, and multiply times the standard rate of 2250, then we'll get the number that goes in the middle here, so we can calculate that direct labor variance, the rate variance. So the actual hours times the standard rate is 1,354,500. And the rate variance, well, the rate variance, subtract the 1,321 minus the 1,355,500, right? This number, actual minus the number in the middle, is going to give us that rate variance. And the rate variance, well, we got a negative number here. It's 33,110, which means it is a favorable variance. Why is it favorable? Why do we have a favorable rate variance? Well, because the rate was cheaper. They only paid $21.95, but the standard is $22.50. So they paid a little bit less, hence a favorable variance, right? So paid less for those actual hours. That results in a favorable variance, negative number, 1,321,390 minus 1,355,500. And then we want to do the same thing for the time variance. So when we look at the time variance, we want to take those 60,000 standard hours and we want to multiply times that standard rate, the 2,250. So the standard cost of this labor is 1,350,000. And we can calculate the time variance by subtracting this 1,350,000 from the 1,354,000. So the 1,354,500 minus 1,350,000 gives us a time variance, positive number, 4,500. That means it is an unfavorable variance. Why is it unfavorable? Well, it's unfavorable because we work too many hours. We work 60,200 hours, but given that output, should only have worked 60,000 hours, hence an unfavorable variance. So the rate variance is favorable because we had a cheaper rate, cheaper labor. The time variance is unfavorable because that cheap labor worked too many hours. And sometimes that happens when you have cheaper labor. Put it all together and calculate the total direct labor cost variance. Well, here we want to subtract the two ends, right? So this number, actual at actual, minus the standard at standard. So here we've got the 1,321,390 minus the 1,350,000 gives us a direct labor cost variance. It's a negative number, right? So we end up with 28,610. And again, that is a negative number, so it's a favorable variance. Negative numbers are favorable variance. And why is it favorable? Well, it's favorable because the actual cost was cheaper. The actual cost of 1,321,390 was cheaper than the standard cost of 1,350,000. So that's the labor model, right? The labor model looks a lot like the materials model. We just give those headings slightly different titles. We're looking at labor hours and rates, not necessarily at quantities and prices that we look at in the materials model. But the concept's pretty much the same. Now, we also have a model that we use for the variable overhead. So when we focus on variable overhead, and let's do that in BE 23-3. When we focus on variable overhead, well, we need two things. We need the actual variable overhead and the budgeted variable overhead, and that will give us the controllable variance. So the actual overhead and the budgeted overhead. And we're given the actual overhead. It's right here. It's 85,900. So the actual overhead is the 85,900. But what's the budgeted overhead? Well, the budgeted overhead, we'll calculate it down here. The budgeted overhead is a function of our output and the standard cost for that output. So we have here, let me just highlight these. We have here output of 8,000 units that should require 7.5 hours at a variable rate of $1.45. So those are the standards that are built into the budget. That's how we get our budget. So again, we're going to take the 8,000 units that should take 7.5 hours. That should cost $1.45 per hour. That's how we're going to get this budgeted variable overhead. So the budgeted overhead, again, the 8,000 hours, 8,000 units. So 8,000 units, and every unit requires 7.5 hours. And the cost for an hour, the standard cost for an hour for variable overhead is $1.45. So put all that together, and that's a budgeted cost for the variable overhead of $87,000. That's the budgeted variable factory overhead. So again, the 8,000 units at a standard direct labor hour of 7.5 per unit times the standard variable rate of $1.45. So the budgeted variable overhead is 87,000, which means we have a controllable variance, and it's a negative variance, right? Because 85,900 minus 87,000 is 1,100. Negative number, which means it is a favorable variance, right? So the 85,900 minus the 87 gives us this controllable variance that is 1,100 favorable. It's a negative number, so it's a favorable variance. So what does it tell us? It tells us that they spent less on the variable overhead than the budget allows for. They only spent 85,900. The budget was 87,000. They spent less, hence a favorable variance, right? A favorable variance. So a cost variance, it's favorable when you spend less, right? It's unfavorable when you spend more. And we've looked at all three so far. We've looked at the materials model, we've looked at the labor model, and we've looked at the variable overhead model. Let's look at a few more. Let's go back to materials. Let's go back to that materials model and calculate those variances for the direct materials in exercise 23-4. So we have some information about the actuals. That's right here. We have some information about the standards. That's right here. And all we need to be able to do is calculate those three variances and then talk about who those variances should be reported to, whom the variances should be reported to. So here's our model. Actual at actual, actual at standard, and standard at standard. And again, we are given all of the information that we need here. So the actual quantity is the 900,000 pounds at 275, 900 at 275. So we've got the 900 at the 275. 900 at 275 is 2,475,000. That's the actual cost of the materials. 900,000 pounds at 275 is 2,475,000. And if we compare those actual pounds at the standard price, which is only 270, we're going to get our variance. And we should know at this point that that variance is going to be unfavorable because the standard is only 270. They spent 275. So we haven't even calculated the variance yet, but we can determine that that variance has to be unfavorable because they spent too much. The price was too high. The price of those materials was 5 cents above the standard. So we're going to have an unfavorable price variance. So the actual quantity, the 900,000 times that standard price of only 270 means that the materials should have cost 2,430,000. And if we want to calculate this price variance, well, we're just going to take the difference between these two numbers. The 2,475,000 minus the 2,430,000. is going to give us a price variance. Again, it's an unfavorable variance. It's going to be a positive number, the 45,000. Unfavorable. Again, it's unfavorable. Why? Well, it's unfavorable because we spent too much. We spent $275 on the materials. The budget only allows for a standard price of $270, hence an unfavorable price variance. Spent too much on those materials. Spent 5 cents more per pound on those materials than we should have. And next, we want to calculate the quantity variance. So here's where we need the standard quantity, and that's just given to us. They tell us here that it's just 916,000 pounds at 270. So that's what we need here. We need 916,000 pounds at 270. So the standard at standard, we should have spent a total of 2,473,200 on those materials. That's what the materials should have cost, right? The standard at standard, 2,473,200. And if we want a quantity variance, then we want to take the difference between these two, right? We want to take that 2,430,000 minus the 2,473,200. That will give us our quantity variance. And that quantity variance, well, it's going to be favorable. How do we know? Because they use less. They only use 900,000 pounds, but given the standard and the output, they should have used 916,000 pounds. So we're going to have a favorable variance. It's going to be a negative number, right? So you're subtracting a larger number from that 2,430,000. It's going to be a negative number. So we end up here, we calculate this quantity variance. It is a negative 43,200. And again, that is a favorable variance. And again, it is favorable. Why? Well, because they use less. The quantity was less than the standard allows for. They use 16,000 fewer pounds than they should have given the standard, hence a favorable variance. And we want to put it all together and figure out a total cost variance. Well, the cost variance is going to be unfavorable, right? Because all we're doing really is netting these two, the 45,000 minus the 43,200, or comparing the two numbers at the end, right? We're taking, in this case, the 2,475,000 minus the 2,473,200. Gives us a cost variance that is 1,800. And that $1,800 variance is unfavorable, right? Because we spent too much. We spent 1,800 more than we should have. We spent 2,475,000 actual costs versus the standard cost of only 2,473,200. Hence an unfavorable materials cost variance. So we are asked to calculate the variances. That's what we did. That's part A. We've calculated the 3 variances. And then who should these variances be reported to for analysis and controls? Well, if these variances are material or significant, well, the purchasing department should be responsible for price variances. And typically the operations department is responsible for quantity variances. So operations or production management, production supervisor, whoever's responsible for using or utilization of the materials, that's who you report a quantity variance to. But price variances are almost always the responsibility of the purchasing department or the purchasing manager. Let's take another look at materials variances, same model, all right? So the model's the same. We just need to be able to factor in the right numbers, the numbers that were given in this exercise, exercise 23-5. So in this case, we are provided with, let's highlight the information that we're given. So they use this crystal LCD display for its products. Each tablet uses one display. That's standard, right? So each unit requires only one display. That's our standard. And then they produce 15,000 of these things. and they only used 15,250 displays. Each one has a standard cost of 190, and they purchased 15,250 at a cost of 27,450. So we got some actuals, right? The actual purchased quantity is the 15,250, and the actual cost is the 27,450. So again, the actual quantity and the actual price. And then we've got some information about the standard, right? So we know how many displays are needed for a tablet. And we have also an idea of what that standard cost is, or the standard price of $1.90. So we've got some basic information, enough to be able to move on in the problem and calculate our variances. So actual quantity at the actual price. So again, the actual at actual, actual at actual. So we've got the 15,250 at an actual cost of 27,450. So they didn't give us the actual price. They just gave us, in this case, 27,450. So 15,250 displays were purchased at a cost of 27,450. If we want to know what the actual price is, well, we can figure it out, right? If we take 27,450 divided by the 15,250 that were purchased, then the actual price is $1.80. That's what they actually paid, right? The total was 27,450. They bought 15,250 of them. That's a actual price of $1.80. Not that we really need it for anything. We have the total actual price paid. That's good enough for our purposes, but it provides us with a little bit more information. And the actual quantity, again, the 15,250 times the standard price. Standard price is right here, $1.90, times that standard price of $1.90. So given that I took the time to calculate the actual price of only $1.80, we now know that this variance is going to be favorable. They only spent $1.80, should have spent $1.90, all for a cost of 28,975. So the direct materials price variance is that 27,450 minus the 28,975, or a price variance that again is favorable because they paid less. So we need a negative number here, right? 1525. Again, favorable because they spent less on these displays than the standard allows for. They spent $1.80, 10 cents less than the standard, hence a favorable price variance. And we also want to calculate that quantity variance. So we need the standard quantity, and well, they give us enough information to figure it out. So it's 15 tablets, right? So if we take the 15,000 of these tablets, 15,000, I'm just going to type in units, it's just easier. 15,000 units, and each one display. Each one needs a display. That gives us 15,000 as the standard quantity. That's what they should have used. They should have used one display for each tablet made, or 15,000. So 15,000 of these tablets times the standard price of $1.90. And what kind of a variance are we going to have? Well, it's got to be an unfavorable variance because they used too many of them, right? They used 15,250 of these displays, but they only made 15,000 tablets. They should have only used 15,000 of them. So the standard here is 28,500, and hence our quantity variance is the 28,975 minus the 28.5. We've got a quantity variance of 475. And again, that's an unfavorable variance, right? Unfavorable because they used 250 more of the displays than they should have, hence an unfavorable quantity variance. And in total, right, when we put all this together, well, the cost variance has to be favorable, right? Because the price variance is 1525 favorable, and that is greater than the quantity variance of 475. So when we subtract the numbers on the ends, right, the 27,450 minus 28,5, yeah, we're going to get a negative number, hence a favorable cost variance. So again, what we need here is 27,450 minus 28.5, the direct materials cost variance, which is a negative number, 1,050. And it is a favorable variance because they spent less on the displays than the standard allows for. 27,450 versus the 28.5. Spent less on those displays, hence a favorable direct materials cost variance. Okay, so I think that's probably enough, at least for now, enough for the materials. Let's continue with labor. We've got a couple more that deal with labor. Let's get those done, and then we'll try to finish this chapter off. So our labor model, right? We're looking at hours and rates, not quantities and prices. So we have some basic information about the actuals and the standards, plug everything in, calculate the variances. So actual at actual. So in this case, they actually work 9,300 hours at 29.50. Actual 9,300, 29.50, and the standard is 30. So we know here that they worked, again, the actual 9,300 hours at 29.50. That should have cost them 274, 350. But what should they have paid for those hours? They actually worked 9,300 hours. Well, the standard is $30 an hour. That's what they should have paid. So they paid a little bit less, right? Which means we're going to have a favorable variance. It's going to be a negative variance. So this number ends up being 279. And when we calculate this direct labor rate variance, this favorable direct labor rate variance, right? It's the 274,350 minus 279. We've got a rate variance of 4650. And again, it's a negative variance because it's favorable. 4,650 favorable variance. So we can highlight the fact that that's favorable because they spent 50 cents less on the labor rate than the standard allows for. Hence, we have a favorable variance, a favorable rate variance. Now, when we look at the time variance, our focus is on comparing the actual hours worked to the hours they should have worked given the output. They should have only worked 9,000 hours. So we already know we're going to have an unfavorable time variance because they worked too many hours. So we're going to need the 9,000 standard hours at the standard rate of $30, which means we should have here $270,000. And again, we're going to have an unfavorable variance. So when we take the $279,000 minus the $270,000, we end up with that $9,000 unfavorable variance. An unfavorable variance because they worked too many hours. They worked 300 more hours than they should have, hence an unfavorable time variance. And when we put these pieces together, well, the cost variance is going to be unfavorable, right? Because they spent too much, 274,350 versus a standard of only 270. That labor costs too much. So we're going to have an unfavorable cost variance. So we're just subtracting the two ends, right? The 274,350 minus the 270,000. We end up with a direct labor cost variance unfavorable 4,350. 4,350. And that's the direct labor variances. Rate variance, time variance, put it all together, we've got a cost variance. Okay, let's take one more look. Oh, we've got a couple more to look at for labor. So let's do those. And for exercise 23.9, so we've got some basic information here about the actuals, right? The labor hours, labor rate, and then the information about the standards. Let's plug all this information in, and then we'll just talk a little bit about, what actually goes into that work in process account. So the actual at actual. So they used 2,600 hours, $32 an hour, and they should have paid $30 an hour. So the actual at actual, 2,600 at $32. So that labor actually cost them 83,200. What should it have cost them? Well, those 2,600 hours should have only cost them $30 each. Right? They spent too much. So we're going to have, in this case, an unfavorable labor rate variance because the labor cost too much. They spent $2 more an hour than they should have. So this is what that labor should have cost them. But instead they spent the 83,200. So the 83,200 minus the 78,000, that rate variance ends up being 5,200 unfavorable. Again, spent too much. They spent $2 more on that labor than they should have. And how many hours should they have worked? Well, they made 500 of these bikes, 500 units, and each bike should have taken 5 hours. Each bike should have taken 5 hours, which means that they should have worked 2,500 hours, standard hours. They should have worked 500 standard hours, right? 500 units should have taken 5 hours a unit. They should have worked 500 standard hours. So the 2,500 standard hours, and each hour should have cost them $30. They should have spent only $75,000 on that labor. But instead, they spent 78,000, right? Because they worked too many hours, right? Too many hours, 100 more hours than they should have. So the time variance is going to be the 78,000 minus the 75,000. And we know that when you work too many hours, you have an unfavorable variance. In this case, it's a $3,000 unfavorable time variance. Put it all together, we know the cost variance is going to be unfavorable. They paid too much and they worked too much, right? They paid too much per hour, $2 more per hour than they should have, and they worked 600 more hours. They worked, 100 more hours than they should have. Hence, an unfavorable rate variance, unfavorable time variance. And when we subtract the two ends, right, the 83,200 minus the 75,000 gives us that cost variance. That's 8,200 unfavorable. 8,200 unfavorable. All right, the combination of these two things, an unfavorable rate variance and an unfavorable time variance. Paid too much, worked too many hours. And in a standard costing system, how much of the labor cost goes into work in process? Well, in a standard costing system, it's the standard cost. So the amount that goes to work in process is whatever you have on the far right here, right? The amount that goes to work in process is the standard cost, right? We want to put the standard cost of that labor into the work in process account, the $75,000, right? This is always going to be that. Whatever you have on the end here is the amount that goes to work in process. Okay, so we have two exercises left, one labor exercise and one variable overhead exercise. So let's do the last labor exercise. Again, same model, and we have some basic information, the actual hours that they work, the actual rate paid, and then the standards. Put it all together in this basic model again. So they actually worked 16 hours and they actually paid them $15.40 an hour. And we know what they should have paid them, 16. So we can calculate, In this case, that rate variance, we know the rate variance is going to be favorable because they got a better deal on the labor, paid them 60 cents less than the standard allows for. So the actual hours, 16, right, times that 1540, paid them a little bit less, right? So that labor only cost them 246. But they should have, for those 16 hours, paid them $16 an hour, which means that that labor should have cost them 256. So we have this favorable variance, $9.60, favorable. And if it's favorable, it's a negative number, right? 960 favorable. So they paid a little bit less for that labor, 60 cents less per hour. How many hours should they have worked though? Well, how many hours should they have worked? Well, in this case, the production was 70 meals, right? They actually prepared 70 meals. So the 70 meals is what they actually prepared, and it should take 2/10 of an hour to make a meal, which means they should have worked 14 hours. That's what they should have worked. They only made, again, they prepared 70 meals. So actual 70 meals. It should take 2/10 of an hour to make a meal. They should have only worked 14 hours. That's our standard hours. So we already know we're going to have an unfavorable time variance because they worked 2 hours more than they should have. So 14 hours times the standard of $16 means we've got a total cost of $224. So this unfavorable time variance, well, the unfavorable time variance is $32. $32 is our unfavorable time variance. So the rate variance, the 246 minus the 256 is the 960. And the 256 minus the 224 is the 32. So let's see here. So I left out just here. Let me make sure I put in everything we need here. That is 256.40. That's why it's 960, because it's 246.40 minus the 256. I'll make sure I give you all the information you need here in this problem. Okay. And again, this is the 224. That's why we end up with 32. Okay. And that last variance, the direct labor cost variance. So here's where we want to subtract the two ends, right? The 246.40, we spent more on that labor than the standard allows for. So we know we're going to have an unfavorable cost variance. Even though the rate was cheaper, right? The time variance completely offsets that rate variance, and we end up with a cost variance. And that cost variance is 2240 unfavorable. 2240 unfavorable. Let me put that at the bottom. That's what I've been doing consistently. So I'll put that at the bottom. 2240 unfavorable. So they spent more on the labor than they should have, right? In total, they spent more because they worked too many hours, right? They worked 16 hours, should have only worked 14 hours, even though the labor was cheaper, 60 cents an hour cheaper, they worked too many hours, hence an unfavorable cost variance. Okay, so that is enough on labor. And then to close this chapter out, the last thing that we're going to look at is the variable overhead. And in this exercise, again, the basic model when we look at overhead is to focus on the actual variable overhead and the budgeted variable overhead. And the difference between the two is the controllable variance. Now, the actual variable overhead is given, 262,000. So I'll go ahead and fill that in. Actual variable overhead is 262,000. Now, how do we get the budgeted variable overhead? How do we get that budgeted variable overhead? Well, the way we normally get the budgeted variable overhead is to take the the hours, right? Those budgeted hours, and they give us that. They give us hours of 14,000, and we want to multiply times the variable rate. Well, so here's what we've got. We've got a standard total overhead of $350,000. And we know that the fixed portion is 90,000. And we also know that the total rate is 25 and the fixed rate is 6. So let's use the information we're given. So the total overhead rate. So the total factory is $25. That's what we're given. We're given a total factory overhead rate of $25, right? The standard rate is $25. So the total standard, and I want to make sure that that is clearly identified. The total standard factory overhead rate is $25. And the fixed factory overhead rate is right here at $6. So let's see here. Less the standard fixed overhead rate of $6 is going to give us our variable rate. It's going to equal the standard variable overhead rate. So 25 minus 6 is 19. So we got to do just a little bit of manipulation to figure out what the variable overhead rate is, but that's okay. It's really not that difficult. Again, whatever the total rate is, subtract the fixed rate, and we've got the standard rate. That's all I've done, right? The total rate is given, $25. The fixed rate is $6, so 25 minus 6 gives us the standard variable rate of 16. And if we want to calculate that overhead, so the overhead is going to be the standard hours, 14,000. So we got 14,000 standard hours. And we want to multiply times the standard rate of $19 times the $19 standard rate. And that's going to give us $266,000. That's the budget for the variable overhead. That's the budgeted variable overhead. $266,000. So the actual is given, and the budget we can figure out by taking the standard hours times the standard rate, the standard variable rate of $19. So the controllable variance got a negative number, right? This variable overhead, they spent they spent 262,000, but the budget is 266,000. Hence, they spent less than that budget allows for. They spent $4,000 less than the budget allows for. Hence, a negative number or a favorable variance. A favorable variable factory overhead controllable variance because they spent a little bit less on that variable overhead than the budget allows for. So we have covered everything that I have assigned in this chapter. Hopefully that is enough to give you what you need to complete the application assignment and the quiz for chapter 23. I'll see you in our last chapter, chapter 24. That's it.